The US just built a weapon that kills drones for 3 cents. A $20,000 drone locked onto a US destroyer. $4 million interceptor loaded. Ready to fire? Helios activates. The drone's electronics fuse. The airframe buckles. It falls into the sea, gone. For 3 cents. This is Helios, a directed energy laser that destroys threats with less power than a microwave. Iran spent $15 billion building a drone army specifically to bankrupt the US Navy. Helios just made every single one of them a 3-cent problem. Here's exactly how. Iran cracked an asymmetric warfare code the Pentagon spent $47 billion ignoring. The Shahed 136 is not a precision weapon. It's a $20,000 invoice mailed to America's defense budget. Iran's aerospace industry produces approximately 3,000 per year. Each one forces a U.S. response. $400,000 for an AMRAAM, $4 million for a Patriot, $10 million for a THAAD intercept. The math compounds in Iran's favor every single launch. Iran-backed Houthi forces launched over 120 Shahed variants in October 2023 alone. Combined proxy drone production averaged 250 to 300 units monthly through 2024 and into 2025. If 30% of those require kinetic intercept and the actual engagement rate ran significantly higher, the US bleeds between $300 million and $800 million per month just restocking missiles used to kill $20,000 drones. The DoD FY25 supplemental request, $2.1 billion specifically for interceptor missile restocking. And here's the detail no headline covered. The US produced approximately 600 Patriot missiles in all of 2025. By April 2026, Operation Epic Fury had already consumed more than 1,200. America was burning through its interceptor stockpile at twice the rate it could manufacture replacements. That is an economic siege disguised as a weapons program. And Iran was winning the math until March 5, 2026. USS Preble, Arleigh Burke-class guided missile destroyer, Persian Gulf, Operation Epic Fury, the joint U.S.-Israeli strike campaign against Iranian military infrastructure. Multiple Shaheds inbound, standard threat package, the kind that had been costing $4 million per kill for 18 months. Helios activates, engagement range 50 kilometers, lock time under 3 seconds, cost per kill 3 cents. Here's what that number permanently deletes. Helios, high-energy laser with integrated optical-dazzler and surveillance. Lockheed Martin, designated Mark V Mod 0, currently installed on exactly one frontline warship in the entire U.S. Navy. The physics are not complicated. A 60-kilowatt continuous wave laser focused at 50 kilometers delivers enough sustained directed energy to bring a drone airframe from ambient temperature to structural failure in under 3 seconds. No intercept trajectory, no proximity detonation, no moving parts, the electronics fuse, the airframe buckles, it falls. The entire engagement cost is the electricity consumed running the emitter for 3 seconds. Roughly the same power draw as a household microwave. There's the number that ends the debate. Shahed 136 unit cost, $20,000 to $50,000 per drone. Patriot PAC-3 intercept, $4 million. The US was running a 200-to-1 cost disadvantage on every single engagement for 18 straight months. Helios inverts that ratio by a factor of 66,000, 3 cents against a $20,000 drone. Iran spent an estimated $47 million building the swarm architecture to threaten a carrier strike group in the Hormuz approaches. The USS Preble's Helios system neutralizes that entire package for under $2 in electrical power. But here's where the physics get more complicated. At 60 kilowatts, Helios is optimized for drones and light surface threats. Iran's Noor anti-ship missile, a reverse-engineered Chinese C-802, sea-skimming at Mach 0.9, unit cost approximately $5 million, gives the system a 4.8-second engagement window at 50 kilometers. At current power levels, that's enough for optical-dazzle, disrupting the seeker head, a soft kill. Not yet guaranteed structural hard kill. That gap, 60 kilowatts current operational ceiling, 150 kilowatts full kill threshold, is exactly what the Navy's SSLTM demonstrator is built to close. The 150-kilowatt solid-state laser technology maturation system was resurrected from storage in March 2025, ran live fire exercises at Diesel Naval Base Ventura County, and destroyed 4 drone targets during the Crimson Dragon multi-contractor wargame. Deployment timeline unannounced. Hardware status operational and confirmed working. The 60 to 150 kilowatt gap is the exact number Chinese and Russian planners are tracking. At 150 kilowatts, the system crosses into hypersonic threat disruption range. The same directed energy physics the F-47's plasma shield deploys at the airframe level, now extended to standoff intercept range on the threat side of the engagement. 2 separate systems. One unified physics-based defense doctrine covering the kill chain from launch rail to cockpit. Iran's standard carrier harassment package, 200 Shaheds in coordinated swarm, 30 C-802 anti-ship missiles, 12 Noor cruise missiles. Combined Iranian expenditure per wave, $9.1 million. Historical U.S. intercept cost for that package at Patriot and Amram mix, $487 million per cycle. Helios integrated across a 10-ship strike group changes that arithmetic entirely. Drone package, neutralized for under $100 in electrical power. Missile package, guidance dazzle on 80% of inbound threats at 50-kilometer standoff. Kinetic reserve for the 20% requiring hard intercept. Total revised U.S. engagement cost, under $2 million, a 99.6% cost reduction per engagement cycle. Now run the decade investment comparison. Iran's total investment in the Shahed asymmetric drone doctrine since 2014, $12 billion in production, $3 billion in proxy distribution infrastructure, Houthi, Hezbollah, Iraqi militia launch networks. $15 billion total. Purpose? Exhaust U.S. naval economics in the Hormuz approaches. U.S. total directed energy program investment over the same period, $6.2 billion. Full fleet Helios integration, $1.5 billion additional. Total U.S. commitment, $7.7 billion. Iran outspent America by $7.3 billion. To build a threat, the U.S. retired for less than half the cost of constructing it. But Helios doesn't close every gap. Directed energy requires line of sight. The moment Iran shifts its threat architecture past the radar horizon, ballistic missiles on lofted trajectories, hypersonic glide vehicles on depressed terminal approach, dispersed inland launch sites beyond the Hormuz geometry, Helios engages from below. The window shrinks, the physics change. That is precisely the scenario the Thor II orbital kinetic system was built for. When Iranian Revolutionary Guard forces established a total maritime blockade of the Strait of Hormuz, Russian-supplied S-400 interceptors positioned specifically to defeat conventional U.S. missile response, geography compressing carrier options to a single approach vector, the Pentagon's answer didn't come from the sea. It came from orbit. Tungsten cylinders, 6 meters long, Mach 10 terminal velocity, sub-meter accuracy, no electronic signature, no radar track, no intercept window at any price. The physics are final. A tungsten rod entering from orbital altitude carries kinetic energy equivalent to a small tactical nuclear warhead, without radiation, without escalation threshold, without any existing defense system capable of tracking it before impact. The atmospheric re-entry plasma sheath renders the projectile radar invisible until milliseconds before strike. There is no S-400 fire control algorithm that solves for an untracked Mach 10 object with zero electronic signature. The blockade cleared in a single engagement cycle. Geographic proximity to a choke point no longer equals strategic leverage when the threat arrives from above the atmosphere. Iran spent $400 million on S-400 integration. Russia charges $500 million per battery. That's nearly $1 billion of layered air defense. The most sophisticated ground-based interceptor network outside of NATO. A single Thor II engagement cycle costs an estimated $230 million, less than half. And the S-400 can't even see it coming. China has 48 operational S-400 batteries across its coastal defense network. Run that math against one afternoon of orbital access. $24 billion of hardware. Neutralized before the first radar ping. Whoever controls orbital altitude dictates the outcome on the water below. The question is whether the Navy deploys fast enough before the next one starts. Drop your read in the comments. Is Helios enough to hold the strait alone? Or does orbital dominance become the permanent backstop for every maritime choke point on Earth? Subscribe and see you in our next videos.